can just follow along visually. All right, so for those of you that I had last year, or like last quarter, I know I went over some rigging stuff. So I know some of you guys have experience with rigging before. I'm going to start this out because like I know I didn't teach everyone. Some of you guys have never done rigging. I'm just going to start this out like from the very basics again. So basically rigging is the process of creating essentially like a fake skeleton for something to move with. So like basically you start out with joints. So first of all, you're going to want to go out of this modeling tab into the rigging tab. And if you start at skeleton, you'll see that there is this button for create joints. And effectively, rigging gives you, again, something to define where you want your model to bend. And if you're thinking of rigging like a humanoid, it kind of works like you would think of a human body. So like if your elbow bends, so you want to have like a joint at your elbow so that it has something to bend there. But before we actually get to that, to actually create joints, you literally just sort of like click on the ground, and you'll notice that it just makes a bunch of these like weird little joints. If we look in your outliner, and again, if you guys have questions, feel free to like stop me and let me know. So this is how the joints are set up in your outliner. You'll notice it's like a giant unholy hierarchy of terror. So the last joint in the hierarchy is the last joint we created, and then it just sort of works its way back down from there. So this is effectively set up with parenting in terms of how these actually work and interact with each other. So like if I grab joint 2 and bend that, it's going to take everything else around it. Same thing with like this other joint. So you can kind of see even like with this ridiculous little example here, like how when I grab this, this is almost behaving like a silly little elbow kind of thing. If we take this joint 4 and do Shift P to unparent it in the outliner, you'll notice that the connection between this joint and this one is broken. And I can now sort of move this one freely. If I grab this like little end joint and rotate that around, you won't really be able to see it rotating, but it's not going to take this stuff anymore with it. So I could either go back in and attach joint 4 back into joint 3 by reparenting it, or what you can do is sort of rearrange joints in your chain, grab like joint 5 and put that under joint 3, and you'll notice that it's changed the way these connect together. So joint 4 is now this weird sort of individual floating joint, and it's been effectively removed from the joint chain. So that's usually what I'll do a lot of times. Like if I accidentally added a joint I don't need, I'll just sort of reparent things and then like just delete that extra joint. You can also go through and have multiple things parented to each other. So again, I've just put joint 4 under joint 3. You notice that 5 and 4 are at the same point in the hierarchy at this point. And if I grab joint 3, it's going to take both joint 4 and 5 with it. So this is good for like stuff like arms, pelvises, that kind of thing. Again, I'll go over like more specific body structures in a few minutes. But this is effectively kind of how joints work on like a very basic level. Are there any questions so far? All right. So let's see here. You will notice so I've bent these joints, and I will disclaimer, like it is a terrible, terrible idea to animate joints. You do not want joints to have any rotation values on them when you're setting up your rig. So like I said, when I originally rotated this, like that rotation is going to explode, probably will explode your rig. So do make sure before you start rigging that all of your rotation values are set to 0. And it sounds really dumb. -0 does not count as 0. I don't know why Maya insists on sometimes putting -0 values of rotation on your joints, but if you see that, you should also make sure that it is set to +0 ? But joints will always have translation values. So you notice like pretty much anyone I click on, they all have some kind of like translate. Seems like most of them are translate X values, and I've rotated this one like a crazy person. Does anyone remember the difference between local and world space by chance? Okay. So I'll go over that really quick. It's like maybe kind of helpful to understand how this rig is set up, but it's not like totally crucial to it. But it is kind of like how joints are set up and established. So you'll notice that Let's go. All right, so you'll notice that like right now, obviously these both have translation values because I moved them away from the origin. So if I go ahead and I like get rid of the translate on this square, it's going to snap it right back to the origin, right? So that's world space. Basically, when the translate values are measuring the distance from the origin itself. And by default, if you make stuff in Maya, with the exception of like joints, whenever you set something up, it's going to be set up in world space in like relation to the origin. If you change that, so you can, if I like take this cube and I'm just going to parent that to my sphere, you'll notice that, so I undid that. Right now, when this is unparented, the translate x is set to -92. I'll parent that to my sphere, and then look at the translation values again, and you'll notice that what was previously -92 is now 4 and 87. And the reason, like what basically happens at this point is instead of measuring the distance from the cube to the origin, it's measuring the distance from the cube to the sphere. So this is local space. It's relation to another object instead of the origin. So it's kind of actually a handy way to set up joints sometimes. So if I go and actually like zero out these translation values, you'll notice that if it lets me do it, there we go. You'll notice that the square actually snaps pretty much perfectly over this sphere. So it can be a really handy way, like again, if you make a joint and you're like, oops, I need to like put this on a ball joint and have it be perfectly in the center. This is potentially one way you can do it. So just use basically like parent it, shift the translate to 0, it'll snap it to the object, and if you unparent it, you'll notice that now instead of being zeroed out like it was 10 seconds ago, it is now, again, a value of like -96 and 87, or -87. So this is, again, gone back to world space. It's not parented under anything, it's just there, and it's now measuring the distance from the object to the origin. Does that make sense? Cool. So actually, now I'm curious. So this is in the same spot as the sphere. So if we click on these, they should share the same translate values. So that's basically the difference between world space and local space. And again, not inherently, it's kind of like a good thing to know in general. It's not like mandatory to understand for rigging. But basically, like if you look at the joints, since these are all parented together, these are, with the exception of this joint, they are all operating under local space. So like this one is apparently 88.4 units away from, I guess, this joint here. So if you were to go in and like zero that out, it's going to snap right back on top of that other joint. Same thing, you can keep going down the line and just like compressing your skeleton. So like I said, joints are designed to have rotation, or I'm sorry, no, bad. Joints are designed to have translate values, not rotate values. So you'll pretty much not be able to get rid of them, and that's totally fine. It's the rotate values that are bad and or problematic. Any questions on that? Yes?
So how can a joint not have rotation values? It's like technically like within the speed of rotation.
So it's looking at everything. They do actually have, okay, so they do have rotation values. They're sort of like baked into the joint. Like if you go into your attribute editor, there's actually, here's like your basic transform, like your translate, rotate, scale, like you would see in your channel box. There's also these other sort of angles for the joint themselves. So this isn't something that you normally would like need to touch or deal with. It's just sort of baked in rotation to the joint. And this is like fine to have actual rotation values in. But effectively it's measuring, you can kind of fudge not having rotation values because it's working as kind of like a point cloud distance from like point A to point B. So let's see, this is like kind of weird to explain. So if you're looking at like point A goes to point B. So right now all you have is a Y translation and a Z translation. So if we look at this second joint, okay, apparently it's only, oh, nuts. But if you're thinking about it like in terms of like spatial stuff, it would be like translating it based on like X units up, X units left kind of thing. So you can effectively like make, by like picking a point in space and sort of like drawing a line between it, you can kind of get away with like out having rotation values. I have no idea if that made sense. Did that sort of help?
So you mean like there shouldn't be any rotation values when you're setting up your rigs, but if you're actually like animating?
Oh, yes.
Could you have rotations?
Yeah, so when you're actually setting up a rig, you never want to animate the joints themselves. So like if I were to like take this joint and just put a keyframe on it and like put another keyframe here, terrible, terrible practice. So you'll never, like the joints will end up inheriting rotation from the controllers that you put on, but you'll be setting up like extra controllers that are what you're going to be using to basically like drive this joint chain. Does that make sense? Okay. So rigs are pretty much like the skeleton, and then the controllers are like the muscles and everything that like normally you would use to control it. Any other questions? All right. Again, please do feel free to stop me. I do actually get really excited when people ask questions because it's like, it tells me that you're paying attention. But anywho. But yeah, so that's like the basics of how joints sort of work. I'll just sort of jump in and show you guys how to start rigging this robot, and just sort of like show you some like random things along the way. So when you're setting up usually a robot or like a humanoid figure, you have the center of gravity in that character. Does anyone know, like if you're doing like a human, where that center of gravity usually is? Yeah. So it's going to be usually like right around the hips or the legs. If you think about it, like if you move your hips, everything else kind of reacts to it. Like your legs are going to react to that. The top of your body gets dragged along with it. So that's kind of like where the center of weight for the human body is. That's where we're going to start our rig for this robot thingy. In this case, it's actually, normally if you're doing like a smooth human, it's more important like where you position that first joint. Since this is just like a hard body, it's kind of less important to an extent. But basically I'm just going to go, again, rigging menu, skeleton, create joints. And in case you guys are wondering, I almost never open the tool settings for this. The only reason I would do that is to like change the bone radius, which I'm actually going to do to like make these hopefully a little bit more visible. Oops. Meh. Reset. Buttons, okay. Cool. So that's purely an aesthetic thing. So I'm just gonna go in and I'm gonna put a joint roughly in the center of this robot's body. Can you guys see that? Is that terrible to see on the projector? Yeah. Okay. Okay, so if you ever do like put a joint down and it's really, really tiny, there's you can go into your like radius here in your channel box and just set that to something maybe like 8, and it'll make the joint way bigger. What you can also do, I mean, for one, getting rid of my grid would help because that makes everything terrible. So what you can also do is like if you want to see your joints through your character, but you don't want to be in wireframe mode because this sucks to look at, go to shading and X-ray joints. And this is like the little menu right above the viewport. And it'll show you your joints through your character. Is that slightly better to see? Sweet. All right, so this is our first joint. I highly recommend as you're going along to just sort of label things as you create them, because like this is a lot of joints to put in. It gets really annoying to go back and like label them later when you're trying to like figure out what everything is. So this first joint, I'm gonna call my root joint. This is pretty much what I start with every time. And again, this is gonna be basically where the center of gravity for your character is. So I'll start with the spine, because that's a fairly straightforward extra like thing to create. And in this case, I mean, you can see I've sort of set up my robot. There's like one ginormous ball joint in the middle of his chest, and then just a torso sort of connected to that. So basically I need this torso to rotate from the center of this ball, and this ball to just sort of rotate in place. And again, depending on how you set up your robot, you can do this a little bit differently. But I will look at first the joint for the torso, because that one's like a little bit, I think, more straightforward. So again, we need this to rotate from the center of this sphere here. So I'm just gonna hit G, okay. Go to skeleton, just do create joints again. I'm just gonna throw a joint there randomly. I should really like set my radius to be larger. And I am going to try to line this up as best as I can with the center of the sphere. I do find it helpful to go into wireframe mode for this. And again, so this is a perfect sphere. So I have two options. I can take this joint and parent it to my sphere. And at this point, it enters local space. I should theoretically be able to, or not. Okay, never mind. Sometimes that works, and it used to work in older versions of Maya and is perhaps not a thing anymore. All right, so the parenting method doesn't super work. So there are other tricks that you can use to get this joint in the center of the sphere. In this case, it's kind of the same thing as I set up last time, like with the pivots in the demo last week. I'm just gonna turn on V for vertex snapping and just drag that on each axis so it lines up perfectly with the center of this little, like pretty much the middle of the ball. You can see it based on the topology of the sphere. And I just also want to go through and make sure, I'm going to hide this cable in the back because it's very annoying, that it's also lined up in the front. So this should be the perfect center of the ball. The other thing that you can do, which like, again, sometimes works really well and sometimes doesn't, is just create like a temporary little locator to sort of place in the center of your sphere. So if you go to create locator, these like are weird stand-in objects, and again, sometimes this works depending on the version of Maya you're in. But it's basically like this weird little sort of stand-in like cross thing. They don't render, they don't really serve much of a purpose except to like mark locations basically. But this you should be able, and you can also snap like vertices to it. So the locator I should be able to parent under my sphere, and if I zero the locator out, you'll notice that it snaps perfectly to the center of that sphere. So if your topology like didn't support snapping to the topology itself, you could add in a little locator. And then what you'd be able to do is grab this joint, like say this was set somewhere really like strange and off to the side. Just again, go into V for vertex snapping and just drag that right to the center of the locator. So if you're doing like weird shaped topology, you just want to like mark the center of joints before you keep working on stuff so that it's easy to go back to later, I highly recommend just like chuck some locators in, parent them to your object, it'll follow it around, and then you can really, really easily snap joints to your locators. Does that make sense? Sweet. All right, so now that the joint exists, I say as I delete the joint. All right, getting rid of the locator. I'm going to just call that the chest joint, and I would like that to be, I would like to be able to see my joints through my skeleton, so again, shading, X-ray joints. So I'm just going to take this joint and parent it to my root joint, and you'll notice that it, connects these two, so if I bend my root, it's going to take the skeleton with it. So basically what should happen at this point is I'm just gonna kind of go in like a spazzy order, and I'll show you everything multiple times. If you don't catch it the first time, don't worry. I'm gonna demo all of this stuff probably like 7 more times while setting up this robot. So we have a joint. I want this to control the chest of this robot, and there's a few different ways that you can do this. The worst way would be to parent this, like parent the chest to the joint. It's going to make your outliner suck, and it's going to be terrible to work with later. If you wanted to, you could constrain this together because it's a hard object. So if you literally just need something like an eyeball, it's not deforming, there's no, like shoulders or elbows you need to worry about with like soft bends. Constraints work really nicely for attaching stuff. So just grab the chest, grab the joint, constrain, and I'll just do a parent constraint. So now if nope, what did I do? Whoops, wrong way. I do that every time. I set up my constraint the wrong way. All right, reconstrain that. Okay, so grab the joint and then your skin and then just do a constraint. Usually I would do like a parent constraint for this because you want it to follow along with the rotation and translation if you're translating this at all. But you'll notice if I rotate this that now the torso kind of rotates very nicely around the center of this little joint here. Yes? So my order was do it the wrong way and then do it the right way, but you should select the joint or the thing that you want to drive the other object, and then the skin or the thing that you want to be moved by an external force. Yes?
So is that one joint, or is the ball not going to have any rotation, or is that joint going to control both the ball and the chest?
Yes. So I'm actually going to add, I tested this earlier, and I found the easiest way to control this was actually to set up 2 joints in the exact same spot, which is like something I don't normally do, but is like a weird fluke of like how I designed this character. So again, it works for this design. Depending on what you guys are doing, it might sort of vary a little bit. And that's the weird thing with rigging is like, you can set up a rig in a bajillion different ways, and half the time they will do exactly the same thing. Any other questions? Yes?
When you set it up, did you parent it to the ball?
I didn't parent it. I used a parent constraint.
But you did it with the torso, would you do it with the sphere?
Yes. So if I rotate this joint right now, it's not moving the circle. It's only moving the top part.
So how did you make it move the circle?
I'll get to that in a minute, but basically I'm just gonna duplicate this joint and have it be an extra joint in the same spot. Because the circle should also rotate from the center of the circle. So we already have a joint there that kind of controls both, and you just duplicate it basically. Any other questions? Okay. All right, so that was mostly, again, I'll go over some of the other skinning and stuff later. For now, I'm just gonna delete this parent constraint so that if I move this, it no longer takes the torso with it. All right, so since you guys have all been asking about like how do we move that little ball, like I mentioned, we're just going to duplicate this chest joint. So we have 2 joints in exactly the same spot. Now, if you look at these, we do need to sort of modify the outliner a little bit, because imagine that this is like a spine. Each part of your spine is connected to the one below it. They're not all connected to your pelvis, because that would be weird and incredibly dysfunctional. And that's pretty much what we have set up right now. So we have 2 chest joints just attached to the same root joint. If I move one, you can see they're not like linearly attached, they're just sort of all glued to the root, which is not what we want. So I'm just gonna grab chest 1, or chest, whatever, doesn't really matter. And I will parent that under this other joint. So I'll just call this one like torso ball. So if we grab torso ball, it should take the chest joint with it. It's just kind of hard to see because again, they're sitting on the exact same point in space. So what we can do now is, I'm just gonna kind of keep going ahead with constraining right now. I'll grab I will grab the torso ball joint that we just added, and then the torso ball itself, do constrain, and do parent constraint. So now if we move torso ball, it's gonna rotate this little ball here, do pretty much whatever weird direction you want. And I will take the chest joint, which I unconstrained, and the chest geometry piece, and, what did I do? And do G, just to repeat my parent constraint command. So now what I have is, if I move torso ball, it's gonna take both pieces of geometry, because torso ball is moving the chest, and this chest piece is actually constrained to the chest joint. So when this moves, it takes the geometry with it. Does that make sense? Cool. So now you can do a bunch of fancy stuff, like having your character, like, I don't know, rotate really weird and be like, what? I don't know. I don't know what this position is, besides broken. You guys are with me right now? Like, it kind of makes sense the way I set stuff up? Yep.
I tried parenting like 2 joints together, and it didn't seem like it connects them like it does there, where there's like a little triangle.
Are they in the same spot, or like?
They're in different spots.
Interesting. Does it, when you look at it in the outliner, does it show up as a hierarchy?
No.
Okay. So if it's not set up in the outliner, it's not going to show up. So, yeah, pretty much the outliner is God when it comes to rigging. So there's like basically 2 different ways to parent it. You can like select the thing you want to be the child, and then the parent object, and then just use P on your keyboard, and that'll just like it's parenting hotkey. You can also grab the object and like middle mouse button drag it under something else, and that's like how to do it with a mouse. Is that working any better?
Yeah.
Sweet. Huzzah. All right, so this is basically setting up the entire chest controls for this robot. At some other point, you're gonna need some controls for like the arms, the neck, the head. It pretty much honestly behaves like the same way. The only thing that I really want to touch on really quick is, so like this, I happen to know that these like default Maya spheres of like 20 by 20 by 20 set up really, really nicely where I can just snap vertices directly to the center of this sphere. But in this case, this is clearly no longer a sphere. It's like a weird whatever shape thing this is. So if you go to like parent a locator to this, it's going to snap to the center of the object. So this is an instance where perhaps, again, geometry works fine to snap it to where joints to where you need them. But this is an instance where, like, before I joined these two spheres together, because it was one sphere and another sphere that I literally just bridged together. I could have parented a locator to each of those so that I would have always a perfect record of where the center of that was. So you can, where am I going? It's like a similar thing here, where in this case, again, the geometry supports it. I still have the pivot left where it is. I've just deleted part of the sphere. So if I wanted to like add an extra arm piece to that, which I will do at some point, just do create locator, and then I'm just gonna take the locator and just parent it under this object here. Also, did anybody, so I assume most of you know like the hotkey for like F of like centering your view on whatever's selected in the viewport. That also works in the outliner, which is like super crazy helpful for rigging. So if you're ever like looking for a joint or something like that, or like looking for a locator, if you find it in your viewport, just hit F in your outliner, it'll snap you right to it. Very, very handy. So I'll just zero out this locator. And, dang it, where are you?
I have a question.
Yes.
How do you single out something like that?
In the outliner, or?
Just in general, like how you have the one ball.
Oh, yes, sorry. So I'm a hotkey monster for the record. If any of you guys, if I do something you don't know what I did, please let me know. It's isolate select. So if the hotkey is Control 1 on your keyboard. Hitting Control 1 will just toggle it on and off. You can also go to show, isolate select, and view selected. And then there's some other random objects about like if you're in isolate select mode and you want to like create a cube, it'll show that cube up because you made it while in isolate select mode. But yeah. Yep. Isolate select is amazing. But yeah.
And then to talk about, you just hit this.
Yep. All right, so let's see here. And this is like one of those strange things where like sometimes locators work beautifully, and in this case, for some reason, it's not working like at all, which is kind of weird and irritating. Yeah. Like I said, I don't really understand how snapping with locators works. Sometimes it's totally perfect, and other times like nah. But as you were going, theoretically, you could just like set up a bunch of locators to like mark where your joints are. So, all right, so what do you guys have a preference between doing like the upper body, which is kind of like an extension of this, or doing legs? I'll do them all at some point.
I prefer legs.
Huzzah! And with that, all of the decisions for all of the classes have been made. I'm doing legs for everyone. All right, so basically when you set up legs, it's going to be kind of the same thing that we've done previously for the individual leg. So I'm just going to do skeleton, create joints. I'm just going to sort of put that kind of close to the center of the leg and like kind of where I need it down here, kind of down there. And if you switch into your orthographic mode, then you can go in and like dump a joint there. So you can see if we look at this, we have this sort of like awkward looking little leg chain set up. And I've actually set up my robot not terribly optimally to be rigged. So when you guys, and this is actually, I did forget to say this earlier, when you guys set up your orthographics for your robot, you should model them with a slight bend in their legs. It's going to make your life a little bit easier when rigging later. Turn this off. So instead of like my character, like it's totally straight going down the leg, what ideally you would want, I'm just going to quickly like parent stuff together, is something kind of like this, where there's like a very, very slight bend to the leg. And again, this is purely for, I mean, for one, it looks a little bit more natural if you're like, it's not like your leg is locked up, but it's also gonna help you with rigging later. So this is, again, please do, when you're modeling your characters and doing your orthographics, In the legs, like the knees and the arms, do put that little slight bend in there. In this case, I'm just going to kind of work with the sketchy little rig that I have. So we have this joint chain, which I've hidden. And again, we just want to go through and make sure that all of these joints are snapped to the center of stuff, to the center of the pivots. Should use real words. One thing you will notice is like so I move this top joint and it takes everything below it with it. If I was happy with the positioning of my ankles and I only wanted to move this knee joint, if you press, so right now it's just like it's moving everything. If you press and hold D, you can move that one joint and it's not going to take the stuff below it. So that can be kind of handy, again, if you need to like modify your elbow or something and don't want to deal with like the entire joint chain moving. You can do it like that. So in this one I've set up, if you look at the geometry, I kind of left this weird like point marker here, which was like the center of the sort of circle-y part of the pivot. So I'm going to use that, and I will just turn on the wireframe. I'm just going to snap that directly to that little center point, and then snap it back so it's like kind of in the center of that pivot. That's not really important. It's just a hinge joint, but it just kind of looks a little bit nicer. So then I'll just sort of keep going down the entirety of the leg. Again, just attaching joints kind of mindlessly into the center of my objects. And this one definitely I will want to double check from like the side view, because it's very much not centered in the side view. So I'll just attach that in there. And I'm just going to ignore the little ball joint for now because I don't know where the heck the center of that is. I did not set that up to be animated well. So here we have basically leg joint 1. I'm just going to go through and like really quick name everything, like left hip, left knee. And so when you're labeling stuff, close enough, for like left leg, right leg, whatever, I would recommend keeping a standard. It doesn't matter what it is, but pick some kind of standard that makes sense for you in terms of naming conventions. So like for left, I always do left underscore. For right, it's always R underscore. You could do, name one side banana and the other side bagel. Like it really doesn't matter, but keep it standard. And the reason I say keep it standard is because you can mirror your joints. So if you go to skeleton and just selecting like the hip joint, skeleton, mirror joints, open the tool settings for this, and basically what it's going to do is copy the joints from one side of your body to the other. And honestly, there's a trick for remembering which axis it is and will work with, which I never remember, so I usually just sort of, okay, apparently it works the first time. Great. So I'll just hit apply, and if it doesn't do what I want, I'll just redo it. Like if it's set to this and I hit apply, like this is clearly not the intended goal of doing that. But again, totally one of those weird things where I just sort of like trial and error to like get the axis I want. And if you want to do, I also usually just sort of ignore mirror function and leave it at the default. But what's really powerful about this is it gives you basically a search and replace, which works just like it does in Microsoft Word. So if I search for L underscore, I can replace it with R underscore. So it should go through, and you'll notice like instead of being like L hip 1, it's gone through and relabeled everything with right hip. So I now do not need to manually edit all of those names. So mirror joints is like super crazy handy. And probably a lot of you guys will be using it very frequently. But like I said, you can replace that with anything you want. You could replace it with banana instead of right. All right, any questions on that? All right, so really quick, I'll just show you how to set up a pelvis and then like pretty much for you guys. But right now we just have 2 awkward floating legs in a body. So these need to be connected to the root joint. I'll show you the bad way to do it and then the good way to do it. So actually, I guess it's actually not a bad way with a robot because it doesn't really matter. So in a human, I usually do like an extra sort of step for this. And it gives you a little bit more functionality, but since this is like a hard body object, I'm just going to go ahead and parent the legs to that root. You'll notice that they're now attached, so if I move the root, it's going to take pretty much everything else with it. And then I'm able to go through and do whatever I want to the legs. And this actually works totally fine for the robots. I'll show you how to do like a nicer one at some point in the future, but we're kind of out of time. So huzzah, we have lovely working legs on this robot. Other thing to note, just like really quick, is you'll notice as I bend this leg, the range of motion is not fantastic because of the way I've modeled this. So like this robot can pretty much only do a 90-degree bend with the knee. Also kind of looks like a creepy skeleton. So I would recommend, again, like testing your robots a little bit, just like parent them together as you're modeling and like bend things and make sure that you can actually bend it the way you need to, so you don't find this out like when you're rigging later. That's pretty much it. Any questions before I free you guys? All right, happy rigging, be free.